Welcome back. After learning the derivation for midpoint circle algorithm and also knowing the algorithm very properly, now we start with numericals on midpoint circle algorithm. Okay, so we are supposed to show the plot of the coordinates that we are getting given a center point and radius, and then generate all the points on the circle to form a circle. Okay. So by now we know that my circle will follow 8-way symmetry as the number of calculations will reduce. Okay, and also we know the start conditions, that is where my x will be 0, my y will be r initially, and I plot these points on the circle boundary. We have also seen what will be there in the plot function. We initialize our first p to p is equal to 1 minus r. Okay, and then my equation starts that by default my x will be incremented by 1. My loop will continue till my x is less than y. So very important point to note down is that my stop condition would be that when my x becomes equal to y, I am going to stop. Okay, so my algorithm will stop as soon as my x is equal to y. We won't go further this. Okay, so my algorithm stops here. That is when x is equal to y. So I'm going to continue this till my x is less than y, and then we are going to see if my decision parameter is less than 0, y will remain as previous y, and we get the new values for p. Else my y is equal to decremented by 1, y minus 1, and I get the new value of p accordingly. Once I get new x and y values, I again plot it on the circle boundary using the plot function that we have already seen. Okay, so we are starting with our first problem, and the first problem says given the center point 0, 0 and radius as 10, generate all points to form a circle. Okay, so now for your simplicity we have given the center points as 0, 0 so that you understand the values and how do you get the calculations, and the radius given to you is 10. Okay, so r is equal to 10. That's my first thing. My x will, my first value of x starts from 0 and my y starts from r, that is nothing but 10. So x is 0 and y is 10. Okay, my initial p value is 1 minus r, that is nothing but 1 minus 10, that comes out to be minus 9. So these are my first values, that is x0, y10 and p is equal to minus 9. So I'm just going to put these values here. My k, I'm going to make a table. Now please understand this table. K is the number of iterations. Xk, Yk are the present values of x and y. Pk is the present decision parameter value. I calculate my next x and y, that is xk plus 1, yk plus 1, and accordingly I calculate pk plus 1 from the equations given to me. Okay. Now, once we are done with this, we will see the how do we get the quadrant plot and the octant plot for these values. Okay, so we are going to start with our iterations. So my iteration number 0, that is when k is equal to 0. My present xk and yk are initialized to 0 and y is initialized to 10. So my x starts from 0, my y starts from 10. Okay, and what is the value of pk? The initial value of p is minus 9. So I'm going to write this value, that is minus 9 out here. Okay, so we are going to see what will be the value of xk plus 1, yk plus 1 and pk plus 1 given the values of x and y as 0, 10 and p value as minus 9. Now, what is p? P is negative. And if p is negative, we fall under the previous criteria that says y will remain as it is and p will be p plus 2x plus 3. And what is x? X is by default incremented by 1. So I pick up xk and I increment it by 1 so that I get xk plus 1. So my xk plus 1 becomes 1. Right? What will be yk plus 1? Yk plus 1, y remains same as y. Okay? Because my value is less than 0. It's a negative p value. So my y will remain as it is, that is nothing but 10. Okay, so what will happen to my pk plus 1? My next value of p is p plus 2x plus 3. So my p changes to p plus 2x plus 3. And what is that value? P plus 2x plus 3. P is what? Minus 9 plus 2 times x, 0 plus 3. So it is minus 9 plus 3. So I get the value as minus 6. So this is your iteration number 0, wherein I am getting my new values of x and y as 1, 10, and my next pk plus 1 is nothing but minus 6. Okay. Now we see if these values are plotted on the quadrant plot. That means if I am considering 4-way symmetry, my values are x comma y, minus xy, minus x minus y, and x comma minus y. So what is getting plotted? It is 1, 10 that is getting plotted. Next value will be minus 1, 10. Next value will be minus 1, minus 10. And the last value that will be plotted is 1, minus 10. So these are the 4 values that will be plotted simultaneously the moment I calculate my new x and y values. And what is getting plotted on the octant? With all these 4 values as it is. So I'll start writing from here. It is 1, 10, minus 1, 10. It is minus 1, minus 10, and it is 1, minus 10. So these are the 4 values as it is, with the new values as y, x. So it will be 10, 1. It will be minus 10, 1. It will be 10, minus 1, and it will be minus 10, minus 1. So these will be the 8 values that will be plotted on all the 8 octants the moment I calculate my next xk plus 1 and yk plus 1 as 1, 10. Now please remember, ma'am has directly written this as xy minus xy minus x minus y, wherein my plot function also says that it is xc plus x, yc plus y. If you remember, our first value. I am giving xc and yc here, but xc and yc currently are what? 0, 0. If it would have been some other value, say if it would have been 100, 100, then I would have added 100, 100 to all the values, and then I have calculated the octant and quadrant plots. Is this clear? Okay. So we move on to our next iteration, and our next iteration starts from 1, right? So when my next iteration starts from 1, my xk plus 1 and yk plus 1 become the current value. So my xk plus 1 is 1, next value is 10, and next pk is minus 6. Okay, so now I start with the calculations again. By default, my x is incremented by 1, so my 1 becomes 2. Okay, so what will be yk plus 1? What is pk? Minus 6. So minus 6, again I go to the previous category. Okay, and the value is y will remain as it is. So my y remains as it is, that is nothing but 10. So my p will be same as p plus 2x plus 3. But now p is minus 6 plus 2 times x minus 2 plus 2 minus 6 plus 2 plus 3. Okay, so minus 6 plus 2 plus 3 gives me a value minus 1. So again I do all the plots, that is with which value? 2, 10. So I'll just show it to you for the quadrant. 2, 10, minus 2, 10, minus 2, minus 10, 2, minus 10. So similarly, you could write it for the octants. Okay. My next iteration starts from 2. Values are 2, 10. And p is what? Minus 1. Again the value is negative. X will be incremented by 1 by default. Y will be decided by p value. P value is negative, so my y remains as it is. And my p will be equal to p minus 1 plus 2 times x, 4 minus 1 plus 4 plus 3. So this becomes equal to 6. Okay. So similarly, you could show your plots. And then at the third iteration, the values are 3, 10 and 6. Okay. So 3, 10 and a 6. Okay. So my value will be 4 because x is incremented by 1. This is positive p. So I go to the else part wherein my y will be decremented by 1. Y decremented by 1, 10 changes to 9. And how am I going to do it? P value is p plus 2x minus 2y plus 5. So p is equal to p plus 2x minus 2y plus 5, right? So what is P? 6 plus 2 times x, 6 again, minus 2y is 20, and then minus 2y is 20, and then last value will be plus 5. So what am I getting the value as in this particular step is minus 3. Okay, so now we move on to our next iteration number, that's 4. So it is 4, 9 and a minus 3. Okay, so my value changes to 5. It is minus 3 again, P value. So my 9 will remain as it is, y will remain as it is, and my P will be P plus 2x plus 3. Right, so what is P? Minus 3 plus 2x will be 8. So minus 3 plus 8 plus a 3, that gives me 8. Okay, so my next iteration number 5, 9 and 8. So now it will be 6. P is positive, so my 9 will decrement by 1, that becomes 8. Okay, so I come to the else part and my P is equal to P plus 2x minus 2y plus 5. That comes out to be 5. Okay, we come to the next iteration number where it is 6, 8 and P is 5. P is positive, so my value changes to 7 and 8 changes to 7 again because it is positive. It is decremented by 1 and my P will be P plus 2x minus 2y plus 5. So my P changes to 6. Okay, now I move on to iteration number 7. But before I move on to iteration number 7, I come to check that what are the values? The values that I am getting here in my xk plus 1 and yk plus 1 are 7 and 7. So this is nothing but the condition when my x is equal to y and my algorithm stops. So this is the stop condition for your iteration. So I want to move on to step number 7 and I have reached my final iteration at step number 6. So these are the points that will be plotted for one octant. Yes, so these are the points that are getting plotted for calculations are done. So there are only 7 calculations that are required to complete a whole circle. For one octant, I calculate these values, and we have also seen how will it be reflected in all the other octants and quadrants as well. Okay, so this is all about your numerical on midpoint circle and how do you solve it. Thank you. So we meet in the next lecture with 2D transformations.